Welcome back, ladies and gentlemen. Today we're going to take a look at 3D objects, but what happens if we change dimensions within them, okay? So it's going to be a little bit of playing on numbers today, so it always just helps just to kind of try things out and see what works. Think about it. If you have a square and you double the side lengths, what happens to the area of the square? So let's just go ahead and, like I said, play with numbers. If I have a square and it's 5 and 5 for my side lengths, my area would be 5 times 5, or 25 units squared. Okay, easy enough. I think we are all cool with squares. But what happens if I double them? So if I made this square now 10 by 10, well, if I do that, 10 times 10, we get 100 units squared. So what's the multiplier here? Well, if I do 100 divided by 25, I know that it is getting multiplied by 4. 100 divided by 25 equals 4. So if you double the side lengths, it's 2 squared. All right, you're at 4, right? So there we go. We're going to keep that in mind as we take a look at surface area. So, right, okay. Practice. Find a change in surface area of the prism below if each dimension is tripled. So I'm going to first find the surface area of this box with just the regular dimensions, okay? So we know that surface area is 2 times area of base plus perimeter times height. I'm going to call this my base, all right? So 2 times 4 times 4 plus my perimeter is 4 plus 4 plus 4 plus 4, and my height is 6, okay? And if I throw all of that in a calculator, I'm going to get 128 meters squared, okay? Just literally 2 times 16 plus 24 times, or I'm sorry, 16 times 6 will give you this, all right? Well, now if I change all these by tripling them, this becomes 12, this becomes 12, this becomes 18. So now I'm going to run the same idea. This is my first one. I'm going to run surface area. Same idea. You've got 2 times my area of my base is now 12 times 12. The perimeter is going to be 4 times 12, because there's 4 sides, they're all 12. And my height is 18. So I'm going to show you guys this one on the calculator. Okay, let's see here. 2 times 12 times 12. Okay, plus 4 times 12 times 18. 1,152. Okay. And it's surface area, so it's still meters squared. Well, I want to know what the change is. So I'm going to take 1,152 and divide it by 128. All right. So 1,152 divided by 128 gives me a change of 9. Okay. So change of 9. All right. So it's just a multiplier of 9. Okay, now let's think about that in relationship to what they said here. Okay, now let's take a look at another example. It's all going to come into place here soon enough. Find the change of surface area of the prism below if each dimension is multiplied by 5. All right. So for this one, okay, what we've got going on is we can take a look. We can say, all right, surface area is pi r squared plus pi rl, slant height. So for my first one, we've got pi, 5 is my radius, pi 5, and my slant height is 13. A little bit of mental math here. It's going to be 25 pi plus 65 pi. Let's give me 90 pi. And yes, I know I can put that in the calculator, but trust me, in this case, it's going to make it a little bit easier if we leave it like that. Okay, oops. All right, if I multiply everything by 5, this becomes 25 meters, this becomes 65 meters. All right, so surface area is pi 25 squared plus pi 25 plus or times 13. All right, same idea. I can't do that one in my head as much. 25 squared plus 25 times 13, 950. Okay. Good. Oop, my apologies. Yep, I knew something was a little bit off. 25 squared plus 25 times 65. Yeah. Make sure you pick the right numbers. That's better. 2,250 pi. So same idea, guys. I'm going to take my second one, 2,250 pi, divide that by, excuse me, 90 pi. Excuse me again. Apologize for that. The pi's are going to cancel out. Okay. So now I've got 2250 divided by 90. And we get 25. Okay. So change of 25. They always come in threes. I don't know what it is, but okay. So write a rule for how to change the surface area of any 3D figure for any multiplier. All right. Surface area, okay, changes by the multiplier squared. All right. So in the first one, we changed it by 3. We tripled it, right? Well, if you square 3, you get 9. Think about it. Surface area is squared, right? Okay. So over here, we multiplied it by 5. It's change of 25. The multiplier squared, 5 squared. So it's going to work across the board for any surface area. Think back up here. We doubled it, 2 squared. Boom. You get the idea. Okay. So good stuff. So we're going to kind of take it from surface area to volume. Hopefully you guys can kind of see where we're going with this. If you have a sphere and you double the radius length, what happens to the volume of the sphere? Okay. So normally your volume formula is 4/3 pi r cubed, right? Okay, so if I do 4/3 pi, if I double the radius, okay, so if I times it by 2, well, when you cube 2, you get 8. All right, so what happens to the volume of the sphere? Well, it changes by a multiplier of 8. All right, 2 cubed, 2 to the 3rd power. So you can kind of already see where we're going with this. Surface area squared, volume is cubed. All right. All right. So if we flip to our back page, moving right along. Much the same on the back here. Find the change of the volume of the prism below if each dimension is tripled. All right. So I'm going to start off with just regular volume. We're going to say 4 times 4 times 6. We can throw that in our calculator. We can get 96 meters cubed. Sorry, I'm kind of avoiding the calculator. It's just punching them right in there. Okay. Well, if I triple everything over here, 12, 12, 18. And so same idea, volume of my triple, 12 times 12 times 18. We're going to end up getting 2,592 meters cubed. Okay. So if I want to figure out the change, I can take 2,592, I can divide it by 96, and we're going to see 27 change, okay? Changes by multiplier of 27, which again, 3 to the 3rd power. You can kind of already see where we're going with this, right? Well, find the change of the volume of the prism below if each dimension is multiplied by 5, right? Volume of a cone is 1/3 pi r squared h, all right? They don't give us h here, all right? So this is one of those Pythagorean theorems, x squared plus 5 squared equals 13 squared, okay? X squared plus 25 equals 169. Subtract that over. Okay, x equals 12. So my height here is 12. Good stuff. So for my first one, it's going to be 1/3 pi. My r is 5. And my height is 12. All right. So we're going to do 12. Let me show you guys this. 12 times 25, because 5 squared. And then divide that by 3. We're going to get 100. So 100 pi. And I'm going to leave pi in there again. 100 pi meters cubed. Okay. Volume over here. Now we are going to multiply by 5. So my radius now becomes a 25. My height becomes a 60. So 1/3 pi My radius is now 25, and my height is now 60. So again, big numbers, 25 squared times 60, divide that by 3, 12,500. Okay. So same idea, I want to see how it changes. So I'm taking 12,500 divided by 100 because the pi's are going to cancel out. Thanks for reminding me about that. Okay, so 12,500, divide that by 100, 125. Changes by multiplier of 125. All right. So write a rule to how to change the surface area of any 3D figure, but for any figure, for any multiplier. So we're looking at, this should be volume. Okay. All right. Well, what happened? Well, so as far as our change is going to be volume changes by the multiplier cubed. Good stuff. Okay. So what happens to the volume when only one dimension is changed? Well, instead of cubing it, all right, if we had to take a guess, all right, we could say something along the lines of volume changes by just the dimensions multiple. So for example, if I only change the length by a certain value, that might only change my volume by that certain value. So let's see a quick example of that. Find the change in volume of the prism below if only the height is tripled. So we already know, because this is the exact same problem as up here, we know our initial volume is 96 meters cubed. Work smarter, not harder. Okay, that's a cubed. So if I triple the height, multiply this by 3, I'm going to get 18. So for this one, it would be 4 times 4 times 18. Okay, 4 times 4 times 18, 288. And if I do 288 divided by 96, we get a change of 3. Okay, change of multiplier 3, which makes sense because I only tripled the height. I only changed one thing instead of all 3. So yeah, just a little bit of extra practice with changing the dimensions around. Hopefully that, guys, helps you out a little bit. But keep up the good work. And as always, good luck. We're all counting on you.